So I'm giving you a quick explanation here about the Conservation of Energy Lab. So the first thing you'll do is you'll grab this balance, so click on that, and then you'll get the AirTrack cart and you'll stick it on there, on the balance, there we go. And it should come up with a mass, and it comes up here with 100.0 grams. That's fair enough. So then we take the cart, we stick it on the AirTrack, and then we get the photo gate, and apparently we've got to put a photo gate around 60 centimeters. I'm not sure where it went exactly. It's at 70.7, so we need to move it down to, it says close to 60. It doesn't say exactly 60. 61.3. I'll move it a little bit closer, but I don't expect I'll ever get it on exactly 60. .9, I think that'll do it. Alright, near enough. So the next thing we'll do is we will take the plunger. Now what I do is I just grab this plunger with the mouse and I move it back. And I'm going to move it back 1 centimeter. And then I will let it go and we'll see what happens. And what do you know? We get this value on the photo gate. It says 0.47. That's 0.47 meters per second. Now you'll notice, actually I'll move this in a little bit. Come on. And this has 210.0 on it. That's just the distance that the cart traveled. You're not interested in that. All you're interested in is the speed and the mass of the cart. So you'll do that for 1 centimeter, then you'll do it for 5, and then you'll do it for 8, and you will investigate what the speed is on the photo gate in each case. Then what you'll do is you'll put the cart back on the balance, and you're going to add some mass to it. Now you do that by double clicking on the cart, and then you can add mass to the cart, make it 200 grams. You hit OK, and you'll notice the new mass on the balance, which you'll look at, and it says here 300.0 grams. Alright, we'll move this back down, stick it on the track, and then we'll move the plunger back and we'll do the same thing, 1 centimeter, and we'll get the new speed. There we go. Alright, so you'll do that for 1 centimeter, 5 centimeters, and 8 centimeters as well, and then we'll go back and look at the lab results. Now this is where you will stick your data. Now the mass here has to be in kilograms. Now to get from grams to kilograms, you'll take your mass in grams and divide it by 1,000. Remember your mass was 100 grams, or 100.0 grams, and to get to kilograms that would be 0.1000 kilograms. Now it's going to round it, it'll be probably 0.10 when all said and done. And the velocity, I think it was 0.47 if we look at it. I think it was 0.47 on the other one. And that's what would go in here, 0.47 meters per second. Then you'll show the data for your 5 centimeters and your 8 centimeters. Now the delta X here all has to do with how far back you pulled the plunger. Now these values are in meters, but this is 1 centimeter, and this is 5 centimeters, this is 8 centimeters. To get from centimeters to meters, what they did was they took the centimeters and divided them by 100. So 1 centimeter to 0.01 meters, 0.05 meters, and 0.08 meters, 1 centimeter, 5 centimeters, 8 centimeters. And this is where they did it again, and this is for the new mass. And I'll let you figure out what the new mass would be in kilograms for the second part. Okay, let's take a look now at the data analysis section with regard to the U sub S and K values. Now the U sub S has to do with the elasticity in the spring, or the potential energy of the spring, and the K here is the kinetic energy of the cart. They actually give you some values here to help you get these, and it's actually not as complicated as perhaps it might look. I'm going to pull up my tablet here. This is a little bit squirrely, I must admit. Give me a second to make sure I get this in the right place. And yeah, this writing part here can be a little bit finicky, so bear with me, please. Alright, I'm going to get the pen ready here. and I'm just going to use this to kind of get some values written. So over here we've got our M, and the mass we agreed was 0.10 kilograms. When you're putting the data in, you don't have to worry about units. If you've got a unit at the top, then everything's assumed to be that unit. And we said that the velocity was 0.47 meters per second. Again, I don't have to put the unit on that either. Now U sub S, they actually give you some stuff here to get U sub S. And they've got U sub S equals little k, half little k, delta x squared. Now the k, the little k value they're using, they actually give you, it's just called the spring constant, and that's 260 Newton meters. So to get U sub S, all I do is to do half times 260. I'm not going to worry about the units here. You shouldn't either. The delta x is, for the plunger, 0.01. And that's squared. Now, to do this in your calculator, what you can do, instead of squaring it in your calculator, which you can do if you want to, is just do this. You can do half times 260 times 0.01 times 0.01. And that'll give you a value for U sub S. And that'll go in here, right here. And I'll let you do that part. Now the K is going, big K, that's big K. There's a different little k here. Little k was a spring constant. Big K is the kinetic energy. And we get that by doing half mv squared. And that's going to be half times the mass, which is 0.10, times the velocity squared. Now the velocity is 0.47, so we do 0.47, and we do times 0.47 because it's squared, just like we did before. And that's going to give us a value. So the whole point of this lab is that you'll put this big K value in here, of course, and you'll have US and you'll have K, and you'll be able to compare these values. And that will be a big part of the conclusion section of this lab. All right, that's it.